Welcome to problems 6 through 8 on the 2024 AMC 10B. As promised, I personally think problems 6 through 8 are much easier than problems 4 through 5. Maybe they look a little bit more daunting at first, but the solutions are pretty straightforward. So let's dive right into it. A rectangle has integer side lengths in an area of 2024. What is the least possible perimeter of the rectangle? So there are two ways to do this problem. Well, conceptually, for example, let's say I have a rectangle of area 25. I'm going to draw here two different rectangles or with different perimeters that both add up, that both have the area of 2025. For example, 2025 times 1 is 2025, and 5 times 5 is also 2025. However, the perimeter of this rectangle, well, it's going to be 5 plus 5 plus 5 plus 5, so 5 times 4, which is 20. However, the perimeter of this rectangle is going to be 50 plus 1, 52. So obviously the perimeter of this rectangle is way bigger than the perimeter of this rectangle. And conceptually, this kind of shows us that when you, for any, well, actually this would be a square, but for a rectangle, if the side lengths are closer to each other in value, the perimeter of that rectangle is going to be much lower than if the side lengths are very far apart from each other in value. So knowing this, let's look again at the problem. All right, so one way to do it is just listing out all of the factors of 2024 and seeing which ones are basically closest together. So I'm going to jot them all down. I'm going to jot them down in pairs. So 1, 2024, 2, okay, so I just jotted down all of the combinations, how to make 2024. So for example, 1 times 2024 is obviously going to give us a rectangle with the largest perimeter. And as you go down the list, the perimeter becomes smaller and smaller until finally you reach these two numbers. 44 times 46 will give you 2024, and the rectangle will have a relatively small perimeter. Well, actually, the smallest perimeter that you can make for a rectangle of this area. However, you might be, kind of thinking, well, obviously, I can do this for maybe a simple number such as 25, where I can list the factors. But for 2024, you don't know, these factors off the top of your head. So in a test environment, when you don't have access to a calculator, this strategy obviously won't work. So I'm also going to show you a much more elegant solution that you will have to use on the test or without calculator or without Google. So it's important to note, I'm going to write like solution number 2. It's important to note that 2025 is actually a perfect square, as it's equal to 45 squared. And 2025 is obviously just 1 less than 2024. And we can actually rewrite 2025 as, we can rewrite 2024 as the difference between two squares. So it's equal to 2025, which is 45 squared, minus 1 squared, which is just 1. And we know that a squared minus b squared is going to be equal to a plus b times a minus b. Therefore, 2024 is going to be equal to, we're going to let 45 equals a and 1 equals b. So in this case, it'll be 45 plus 1 times 45 minus 1. Therefore, 2024 is going to be 46 times 44. And again, we get back to these exact, so this was a much more elegant way of doing it. It does require you to realize that 45 squared, or 2025 is a perfect square, but this way you don't have to go through the entire factorization of 2024. Well, we didn't answer the problem yet. The problem is asking the perimeter at the end of the day. So you have to add these up, which is going to give you 90, and obviously multiply by 2 to get 180, which is going to be your answer, which is also answer B. All right. Okay, so this problem, I'll read it out first. What is the remainder when 7 raised to the 2024 plus 7 raised to the power of 2025 plus 7 raised to 2026 is divided by 19? This problem, quite frankly, looks impossible at first if you don't really understand what to do. The trick is, well, let's just first factor out 7 times 2024. This is maybe relatively obvious, as you will get 1 plus 7 plus 7 squared. And to simplify this, well, this is 49, so 49 plus 150, 57. And again, even though I've simplified it right now, the problem still looks impossible. However, we know that 7 times 2024, well, we know that 57 is actually equal to 19 times 3. So we can rewrite this as so. And it's asking for what is the remainder when this is divided by 19. Well, if you're dividing this by 19, the 19s are quite obviously going to cancel out. So your remainder is going to equal to 0. So there you go. It looks like a very daunting problem. But once you do the first semi-obvious step of factoring out 7 to the 2024, you realize you have 57, which can be broken down into a 19, and therefore the 19s cancel. You're left with a remainder of 0, which is option A. All right, let's move on to the last problem, problem 8. Let n be the product of all the positive integer divisors of 42. What is the units digit of n? Well, for this, there's no way really around it, but to look at the positive integer divisors of 42, and unlike the example up here with 2024, it's very easy to find them all. 1, 2, 3, 6, 7, 14, 21, and 42. So obviously, if you were to multiply all of these together and then find the units digit, that would waste a lot of time of your test. So, but because it's only asking about the units digit, well, you only have to multiply the units digit together. So 1 times 2 will give you 2. 2 times 3 will give you 6. 6 times 6 will give you 36. And now, again, I'll demonstrate it once, but 36 times 7 is going to give you 2, 4, 21, 25. However, you don't even need to look at this part of the expression. All you really care about is multiplying 7 times 6, which is going to give you 42. And all you care about is the integer digit. So this is going to give you 36, but I'm not even going to, well, I'll write 252. But then I'm not going to multiply 14 by 252. I'm just going to look at the units digit and what happens when I multiply them together, which is going to be 8. And I'm going to continue this. 8 times 1 is going to be 8. 8 times 2 is going to be 16. And the units digit of 16 is obviously 6. So that is going to be our answer. Answer D.